Hello friends. Welcome back to my channel Calibration Academy. If you are new on this channel, please subscribe to our channel and press bell icon to get notification. And if you like our content, please press like button, it really help us. And if you need video on some specific topic, please let us know in comment box. In today's video, I'm going to show different conversion methods to calculate 4 to 20 milliamperes signal of transmitter. First of all, you will learn what is square root extractor. Secondly, you will learn linear milliampere to square root milliampere conversion formula for DP transmitter. You will also learn linear percentage to square root percentage conversion formula. In addition to this, you will also learn how to calculate maximum flow rate and differential pressure of DP transmitter. And last section of this video, I will show graphical conversion method to convert 4 to 20 milliamperes signal into percentage. So, please watch this video till the end, so that you don't miss any informative information. First of all, what is square root extractor? As we know that, the relationship between flow rate and differential pressure is nonlinear. In other words, flow rate is directly proportional to square root of differential pressure. Or we can say that differential pressure developed by orifice plate or any other acceleration-based flow element is proportional to square of the flow rate. So, square root extractor is an electronic or pneumatic device that takes the square root of the signal from the flow transmitter and produce outputs corresponding to linear flow signal. In other words, it takes square root input milliampere signal from DP transmitter and converts it into linear milliampere signal. As you can see from the picture that the square root function was performed in a separate device called a square root extractor in the days of pneumatic instrumentation. Nowadays, all the smart DP transmitter comes with square root extractor function. In other words, user can select square root extractor function from transmitter. Now, let's try to understand linear milliampere to square root milliampere conversion for DP transmitter. As you can see, this is a standard formula in order to convert any linear milliampere signal to square root milliampere signal. In this formula, you just need to put linear milliampere value, and it will give square root milliampere value corresponding to your linear milliampere signal. For example, if linear analog output is 5 milliamperes, what is square root output for this input? Now we have the formula. So, put 5 milliampere in this formula. And after this, it is simple math calculation. As you can see from this example that, we have not changed any other value except linear milliampere value. This simple formula is enough to convert any linear milliampere value into square root milliampere value. So, in this example, square root output is 8 milliampere for 5 milliampere linear signal. Let's take second example. If linear output is 8 milliamperes, what is square root milliampere output for this input? Now, put 8 milliamperes in this equation, and do the simple math calculation. So, it will give you 12 milliamperes value. In other words, square root output is 12 milliamperes, when linear input is 8 milliamperes. Let's take third example. If linear output is 13 milliamperes, what is square root milliampere output? Now, put 13 milliamperes in this equation, and do the simple math calculation. It will give you 16 milliamperes result. So, square root output is 16 milliamperes, when linear input is 13 milliamperes. Now, let's try to understand square root milliampere to linear milliampere conversion. So, this is a standard formula for square root milliampere to linear milliampere conversion. You just need to put square root output milliampere value, and it gives linear output milliampere value. Let's take one example to understand this conversion. If square root output is 6 milliamperes, what is linear output? So, put 6 milliampere in this formula. After this, it is simple math calculation. As you can see from this example that all values remain same except square root milliampere value. In this example, calculation result is 4.25 milliampere. In other words, linear output is 4.25 milliampere for 6 milliampere square root output. Now, let's try to understand linear percentage to square root percentage conversion. This is a standard formula for linear percentage to square root percentage conversion. In this formula, x is linear percentage value. Let's take this example to understand this conversion. For example, convert 50% linear to square root percentage. So, we will put 50 in our formula. So, square root of 50 is 7.071, which is multiply with 10. And it gives 70.71. It is simple math calculation. Now, let's go to next example. Convert 75% linear input to square root percentage output. Let's put 75 in this formula. Square root of 75 is 8.660, and it multiply with 10. Which gives 86.60. So, square root output is 86.60 for 75% linear input. To calculate maximum flow rate and differential pressure in following example. So, first of all, we will write down all the information, which is already given in this example. As you can see from the picture that, flow rate is 11.65 GPM in this example. 0 to 32-inch H2O is the range of flow indicator transmitter. And square root extractor is being used at transmitter end. 10.7 milliamperes is the output of transmitter. Now, by using this information, calculate maximum flow rate. Then find differential pressure. Lastly, calculate flow controller output. Step number 1. Find process value or differential pressure value. In order to find process value, we have standard formula to calculate process value from milliampere, lower range value and upper range value. Now, put milliampere value, lower range value and upper range value in this equation. And do the simple math to find process value. When you do the math, you will get 13.4-inch H2O as differential pressure value. Now, convert this differential pressure or process value into percentage. In order to convert process value into percentage, put the values in this equation. And do the simple math calculation to find out percentage value. You will get 41.88%. Step number 2. Find maximum flow rate. As we know that, flow rate is directly proportional to square root of differential pressure. Now, put 41.88% in this equation, and take square root of this value. You will get 64.71%. This is the maximum flow rate in percentage. Now, convert this maximum flow rate into GPM. When you put values into equation, you will get 18 GPM maximum flow value. Step number 3. Find flow controller output, when maximum flow rate is 64.71%. In this example, flow controller range is 1 to 5 volt. It means that, minimum range is 1 volt and maximum range is 5 volt. And maximum flow rate is 64.71%. Now, put all these values in this standard equation, and do the simple math to find out controller output. When you do math calculation, you will get 3.59 volts. In other words, flow controller will generate 3.59 volts, when maximum flow rate is 64.71%. In this section, we will learn about standard formula to calculate 4 to 20 milliampere from percentage. As you can see, this is a standard formula to convert any percentage process value into milliampere value. Let's understand this formula by taking one example. Example. Calculate the milliampere for 60% of signal. Now, put 60% in this equation, and do the simple math calculation. In other words, we need to put 60% in place of x in this equation. When you do math calculation, you will get 13.6 milliampere value. First of all, let's learn how to convert 15.2 milliampere signal into percentage by using graphical calculation method. As you can see from this graph, this thick line is 11.2 milliamperes long. In other words, it is the distance between 15.2 milliamperes and 4 milliamperes over the total length of 16 milliamperes. So, to convert 15.2 milliampere signal into percentage, divide 11.2 milliamperes by 16 milliamperes, and multiply it with 100. And do the simple math calculation, it will give you 70%. Let's take one more example to convert PSI signal into milliamp signal. As you can see in this example, I am going to show how to convert 11.4 pounds per square inch signal into milliamp signal by using graphical calculation method. As you can see from this graph, the thick line is 8.4 pounds per square inch long. It is the distance between 11.4 pounds per square inch and 3 pounds per square inch over the total length of 12 pounds per square inch. So, to convert 11.4 pounds per square inch signal into milliamps, divide 8.4 pounds per square inch by 12 pounds per square inch, and multiply it with 16 milliamperes. And add 0 offset of 4 milliamperes, and do simple math calculation. You will get 15.2 milliamperes. In other words, 11.4 pounds per square inch signal is equivalent to 15.2 milliampere signal. Thank you friends for watching this video. If you like our content, then please hit the like button. It motivates us to make more informative videos like this in future. And please share this informative video with your friends.